Hi, smart learners. Welcome to today's episode on basic operations with arithmetic. So, in our last video, we discussed how to use multiplication, and I believe by now you should know how to solve multiplications by digits using the decomposing method and also using the long multiplication method. So, today we'll be looking at division, and division is quite simple. It's quite simple. You have to also understand how multiplication works. Very, very important in division because division and multiplication are kind of inverse of each other. So you have to know how multiplication works so as to know how division work as well. So your multiplication table is also one of the things you have to know before you can start division as well. So let's start with. So our interest today is on division. So we are basically doing division today. So let's start with example one. I have 228 divided by 4. So we're going to use the long division method. The long division is very simple. So what we just do is, in mathematics, this 228 is our number, the one we want to divide. This 4 is our divisor, what we are using to divide the number, and whatever we get after using 4 to divide 2 to 8 is called the quotient. So the answer we get is called the quotient. But really, that's not really very important at this level. But you can also know that it's not a problem. So we have the after this division, I'm going to label each of the parts so that I can know what is what and what is what. So yeah, I'm going to put this 2 to 8. I'm going to put it in the inner bracket 2 to 8. Then I can put 4 outside here. Yes, 4 outside. So can 4 go in 2? That's not possible. So I have to take two digits, 2 and 2. So since 4 cannot go in 2, I'm going to take the first two digits here. Is what I'm going to take. The first two. That is going to ease our division. So 4 in 22. So 4 can go in 25 times. So that's 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, 4 times 5, 20, 4 times 6 is 24. So I can't go beyond because I have 22. So I can't go beyond 24. So I have to stop at this point here. So I'm going to write 5 here. So 5 times 4 is 20. So I want to subtract that. It's very, very important. You do not have to, it must not get to 8. So it has to be at the bottom of 22. So 22 minus 20, that gives 2. Then I'm going to drop my 8 here. So 4 in 28. So what I see is 24. 4 times 7 is 28. So that is 7. So 7 times 4, that's 28. I also want to subtract again. So I have what? 0, 0. So we are through with what? With this. So here now, if I want to label the part, this is my divisor. This is my quotient. And it's also very possible that I have a remainder after subtracting. So that is going to be my remainder. And this is the number I'm dividing. I'm dividing 2 to it. So we can also do this without using the long division method. It's very, very possible. So, but that comes with a bit of advancement in mathematics. Not much of advancement, but at least you have to understand some basic things. So in divisibility, we have something we call divisibility rule. So I'm going to tell you the divisibility rule for 2 or for 4 now. So you know 2 is going to go in a number if that number ends with an even digit. So 2 to 8. 8 ends with an even digit. 4 also is also even. So that means 2 can go in both of these numbers. So 2 here, 2. 2 in 22 is 11, because 2 times 11 is 22. Then 2 in 8 is 4. Also, can 2 go in this both? Yes, 2 can go because 2 here, 2 is even, and the last digit here is also an even number. So 2 in 11 is 5. remainder 1 because 2 times 5 is 10, remainder 1. So you put the 1 on top of the next digit, 4. So 2 in 14, that's 7. So we still have our 57. It's also very much possible in this form. Let's take the next example. I have 182 divided by 7. What do? We use our long division method. 182. Our divisor is going to be out. So 7 in 18, because 7 cannot go in 1, so I have to take the next two digits. So 7 in 18. 7 in 18 gives 7 times 1, 7. 7 times 2, 14. 7 times 3 is 21. So I know I have to be here. So 7 in 18 is 2. 2 times 7 is 14. So I want to subtract. It's very, very important you subtract. 18 minus 14 is 4, not 2, 4. Then you drop the 2. So 7 is 42. So we do 7 times 4, 28. 7 times 5, 35. 7 times 6, 42. So 7 in 42, that's 6. So 6 times 7, that's 42. Then we subtract 42 minus 42, that is 0. Again, 26 is our quotient. 26 is our quotient. And we have no remainder. So we can also use the division method to do this by 7. 7 in 18, that's 7 times 2 is 14. So 7 here 1. 7 in 18, that's 2. Remainder 4. So you put the 4 to the next digit. So 7 in 42, that's 6. So we have 26. Good. So let's check with a number that's going to give us a remainder. Now let's check with that. Let's see, I have example 3. I have 275 divided by 8. So I'm going to do long division. 275, 8. 8 in 27. So we have 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4 is 32. So I know I have to stay within this range. So 8, that's 3. 8 in 27, that's 3. 3 times 8 is 24. So I have to subtract. So I'm going to drop the 3. Minus 27 minus 24 is 3. So 8 in 3 is not possible. Because this is a remainder, we are just going to drop this 5. So 8 in 5. 8 in 35, sorry. So I have 8 times 4, 32. 8 times 5, 40. So I now have to be here. So that's 4. 4 times 8 is 32 from here. Then we subtract 35 minus 32. That gives us 3. So here we have a remainder. So I have my quotient to be 34 and my remainder to be 3. So the answer is 275 divided by 8 is what? 34, remainder 3. As simple as that. So let's take another example. Here we still have a single digit. 1720 divided by 8. It's example 4. So I'm going to use my long division, not square root, sorry. Long division. 1720 divided by 8. So 8 in 17, I have 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. So 8 in 17, that's 2. 2 times 8 is 16. So I want to subtract 1. 8 in 1 is not possible. I have to drop 2. 8 in 2, that's 1. 1 times 8 is 8. I have to subtract. 12 minus 8, that's 4. 8 in 4 is not possible. I have to drop the next digit, 0. So 8 in 40 is 8 times 4, 32. 8 times 5, 40. So that's 5. So 5 times 8 is 40. So now I subtract. So no remainder in this case as well. And my quotient is 2.5. So 17820 divided by 8 is what? Is 215. So let's use the number division method and see if we are going to get the same answer. So we know 2 can go here. Yes, 2 can go. 2 in 8 is 4. We are sure 2 can go here because 0 is even and 8 is also an even number. The last digit is going to tell us if 2 will go or not. The last digit. So 2, 4. So 2 in 17, That's 8 because 2 times 8 is 16. So remainder 1. So you have to put the 1 here. 2 in 12, that's 6. Then you have a 0. You just put the 0. 2 can go as well because this is still even. 2 here, 2. 2 in 8, 4. 2 in 6, 3. Just put the 0. So we have 2 can still go. 2 here, 1. 2 in 4, 2. Remainder, nothing. So 2 in 30, that's 15. So we have 2, 1, 5. As simple as that. Just in this case, we are cutting, cutting, cutting. But you have to ensure that your knife is so sharp. And what is going to make your knife sharp? It's how vast you are with your multiplication table. So it's important for you at this level to know from table 2 to table 10. Do not forget from table 2 to table 10. Good. So let's see another example. Example 5. I have 1620 divided by 12. So you can see we want to do 2 digits now. Yeah, 2 digits. So 1620 and 12. So 12 and 16, that's 1. 1 times 12 is 12. I want to subtract. So I have 4, 2. Let me just write 4. 12 and 4 is not possible. I can drop the 2. Good. So 12 and 42 now. So let's see 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. So 12 and 42, I can only be here because 48 is more than 40, 48 is more than 42. So 12 in 42 can be 3. Then 3 times 12 is 36. Subtract. So I'm going to borrow from here. This becomes 3. Then that one is going to become 10. Then 10 plus 12, that's 10 plus 2 is 12. So 12 minus 6 is 6. 3 minus 3 is 0. Good. So I can just drop this. 12 and 6 is not possible, so I just drop 0. Good. So 12 and 60. So let's do it one more. 12 times 5, that's 60. Good. So 12 and 60 is 5. So 5 times 12 is 60. And I subtract, I have what? Nothing left. So you can see that this is also very simple. You just use the same rule as division. So let's see more digits. Let's see example 6 now. Example 6, yes. So I have 392 divided by 17. So I have 392, then I have 17. So 17 in 39. 17 in 39, that's going to be 17 times 1 is 17. 17 times 2 is 34. So we know it can only be 34 because the next is going to be by additional 17 to 34. So let's just stop at 2. So 2 times 17 is going to give us 17. And let's subtract. Sorry, 2 times 17 is going to give us 34, not 17. 34, that's a 34. Let's subtract. So I have 5. I have 2. Or let's say I have 5. 9 minus 5 is 4. I'm going to write this correctly. 5. So 17 and 5 is not possible. So I can just drop 2. So 17 and 52 is, let's do 17 times 3 again and see what we have for 17 times 3. So 17 times 3 is going to be 51. Yes, 51. So we can see that we don't even need to do the next one. All right. If we want to do 17 times 4, that's going to be 68. Yeah, 68. So we can see that we only have to stop at 3 here. So 17, we have 3. 17 in 52 is 3. 3 times 17 is 51. Then we subtract, we have 1 as our remainder. 17 and 1 is not possible, so we just leave the answer like this. So we have 392 divided by 17 gives what? 23, remainder 1. Simple as this. Okay, so let's look at a more longer division. Let's see 78443. 78443 divided by 23. Okay. 78443 divided by 23. So we have our long division. 78443 divided by 23. Okay, good. So we want to do 23 in 78. So let's do 23 times 1, 23. 23 times 2, that's 46. 23 times 3, that's 69. So 23 times 4, 23 times 4, 4 times 3, 12, 2, 1, 4 times 2, that's 92. 23 times 5, you can always confirm by using your multiplication. So 23, 5 times 3 times 5 is 15, 5, 1, 3 times 2 is 10 plus 1, that's 115. So 115. So you need not think that because I'm the instructor in mathematics, that's why it's coming easy for me. No, 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 no. It's also something I'm accumulating in my brain. Okay, so 23 is 78. So we can only say that we can only be here. So that can only be 3. So 3 times 23 is going to give us 69. Now let's subtract. 7 minus 6 is 1. No, no, no. Don't do it that way. It has to be from the unit here. So this is going to be 0, 1, 18. So that's 9. 23 in 9 is not possible. So we just drop 4. So 23 in 94, that's here. That's going to be 4 remainder 2. So 4 times 23 is going to be 92. Then we subtract. We have 2 remainder. So we drop 4. Plus 23 cannot go into. So 23 in 24, that's 1. 1 times 23 is 23 subtract. It's going to be 1. So 23 in 1, that's not possible. So we drop 3. Now 23 in 13 is not possible. That's 0. Because this thing is not a remainder. So that's why we are just writing 0. So 0 times 23 is going to be 23. So when we subtract, we know we have our remainder to be 13. So 0 times 23 is 0. So when we subtract, we have our 13 as our remainder. So when you divide this by this, your answer is going to be 3410 remainder 13. 3410 remainder 13. So I want to believe you understood this clearly. But there are something I want to just explain before we round up today's class. In our next class, we'll be looking at what problem with multiplication and division, and that's going to be all for numbers. So we are going to be moving into fractions. So, and fraction is so mind-blowing, so simple, very, very simple. If you like dividing chocolates with your younger ones or your elder ones, then you're going to enjoy fraction, because fraction is just what it's just more like expressing divisions in what in numbers. So when we get there, you're going to enjoy the whole fun. But before I call up to this class, I want to just expose you to divisibility rule. So how do we know that a number is going to divide another number? Let's say, for example, I have 24 and I have 2. 2 is going to divide this number. How do I know? Because the last digits of each of the numbers in the numerator and in the denominator are what? They are even. So if the last digit is even, comma, 2 will divide. So here 2 can go in 24. Why? Because the last digit here is even. So let's say another example, 103 divided by 2. 2 cannot go. As in, it means that 2 is not a perfect division. So when you use 2 is not a multiple of that number. So when you use 2 to divide that number, you're going to get a remainder. That's what I mean by divisibility rule. So 2 in 24 is going to give you 2 year 1, 2 in 2, 1, 2 in 4, 2. So 2 divided by 24 is going to give us 12. Without a remainder, you can see 2 is a multiple of 24. But 2 in 103, that's going to leave us to a remainder. So 2 in 10 is 5. 2 in 3 is 1. Remainder 1. So you can see in this case now, we have what? We have a remainder. So that's what I call divisibility rule. So let's check for 3. 3 is going to go in a number if, when you sum up the numbers together, when you sum them up, let's see, 24 divided by 3. 3 is going to divide this particular number without a remainder if, when you add each of the digits together, you get a multiple of 3. What I mean is that 2 and 4 are the only digits you have here. So just add them together. 2 plus 4 is what? 6. Can 3 divide 6? Yes. That means that 3 is going to divide 24. So if you add the digits together, and the sum you get after adding together is a multiple of 3, then 3 is what is going to divide that number without what? Without a remainder. So 3 in 24 is 6 because 3 times 6 gives 24. Let's look at a very big number. 1, 2, 2, 1 divided by 3. 3 is going to divide this number. How do I know? Just add it together. 1 plus 2 plus 2 plus 1. That gives what? 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 1 is 6. That gives 6. So since 3 can divide 6, can 3 divide 6? Yes. Then 3 will divide 1, 2, 2, 1. That's just the rule. So let's divide now and see. 3 here, 1. 3 in 1 is not possible. So we just say 3 in 12, that's 4. So 4. 3 in 2 is 0. Then 3 in 21 is 7. So we have 407 as our answer. 407. So you might also be interested in checking if 3 will divide 407 itself, because as I'm looking at it, I think it will or it will not. So let's see. Can 3 divide 407? Let's add together and see. 4 plus 0 is 4. 4 plus 7 is what? 11. So 3 will divide 11 with a remainder. So there will be a remainder in this case now, because 3 is not a multiple of 11. So let's see that and confirm. So 3 here, 1. 3 in 4, that's 1. Remainder 1. 3 in 10, that's 9. 3 in 10 is 3. Sorry. 3, not 9. 3. 3. Remainder 1. 3 in 17, that's 3 times 5, 15, 5. Remainder 2. You can see it has a remainder. But let's see. Let's assume we have 417 divided by 3. 417, when you do 4 plus 1 plus 7, you have what? 4 plus 1 is 5. 5 plus 7 is 12. So 3 can go in 12. That means 3 can go in 417. Let's confirm that. 3 in 4, that's 1. Remainder 1. Yes. 3 in 11, that's still 9. Remainder 2. 3 in 27, that's... Sorry, 3 in 11 is not 9, it's 3. I'm saying 9 again, it's 3. 3 in 11 is 3. Remainder 2. Plus 3 times 3 is 9. So 11 minus 9 is 2. So 3 in 27 gives what? It gives 9. 3 times 9 is 27. So you have 139. You can see. Can 3 go in this number? 1 plus 3 is 4. 4 plus 9 is what? That's 13. So 3 cannot go in 13. So that means 3 is not a multiple of 139. As simple as that. And the other cases you have is for 5 and 10. So for 5, if the last digit is a multiple of 5, then 5 is going to go. For example, if you have 625, then 5. So the last digit, 5 can go in the last digit. So that means that 5 can go in this number without a remainder. So let's have another example, 620. 0 is a multiple of, or 20 is a multiple of 5. So that means that 5 is going to divide 620 without what? Without a remainder. Also, the same thing goes for 10. So if the number ends with 0, then 10 is going to divide. So like 620 divided by 10, or 6210 divided by 10. This is very simple. So 10 is going to divide. And also 3 is going to go in this number, 621, because when you do 6 plus 2, that's 8. 8 plus 1, 9. 9 plus 0 is still 9. So 3 will divide this number. 10 is also going to divide this number. 5 will also divide this number. 2 will also divide this number. So the multiple of 62110 is what? 2 is going to divide without a remainder. 3 is going to divide because when you add these three numbers, when you add these digits together, you have a multiple that 3 can divide. Also, 5 is going to divide because it ends with 0 or it ends with 10. Also, 10 is going to divide because it ends with what? With 0. So that's just a summary of the divisibility rule. I hope you enjoyed this video. Do not forget to hit the like button. And also, if you have any question concerning what we just explained today, do not be scared to ask questions as always. And kudos to you for turning in your assignments and your task in regularly. So see you in the next video on the next tax. On to the next tax. See you in the next video. Bye.